The refraction of a light. What is a refraction of a light? When a light goes one medium to another medium, it changes its path due to the medium. Suppose there is a air and another medium is a water. Okay, this is a water and upper medium is a air. So whenever light goes from rarer medium to denser medium, suppose this is normal which is perpendicular to the medium, so whenever the light goes, it's make incident angle here, it goes in denser medium, it not goes directly straight, it little bit bend in. So whenever it goes rarer medium to denser medium, it bend in, or just reverse, denser medium to rarer medium, it's bend away, like this is bend away. Okay, so this is the refraction of a light. Why this is happen? Cause of refraction, it is happen due to the speed of the light. Speed of the light is changes due to the medium. Obviously, when the light goes denser medium, its speed is slow down. So understand here, you might be observed that bottom of a tank or a pond contain water appears to rest. So why this is happen? It is also happen due to the refraction of light. So there are so many example other, like example of pencil appears to be displaced to the same extent if instead of water we use to liquid kerosene and turbinate, the refraction is change. So activity 10.7 is the belongs to the refraction, in which you take a water, a bucket, anything full of water, and place a coin into the bottom. Okay, suppose here. So the visual appearance when the water is filled here is different, and depth is also changed when the water is filled. So it is happen when the water is poured in it, so it become denser. So the light which is comes from coin to strike our eyes, suppose from upper side we see the coin, though then you know that the light is bent away. Suppose it is full of water here, so when you know that light is straight in moving in a straight path, so it's appear here, your coin is appear here as a raised. Okay, next activities also belongs to the same, you can perform with the bowl also. Activity 10.9, draw the thick straight line in a ink over a sheet white paper placed on a table, and now you watch it by the glass slab. So it appear raise or it's change its path. Suppose how it is looks like. So you draw a line like this, and when you place a glass slab here, it appears its rays, it looks different due to the refractions. Okay, it is the denser medium which is called glass, which is denser with air, upper medium is the air. Okay, it is also happen due to the refraction. Now another point is refraction through a rectangular glass slab. So basically here upper medium is a air and the lower medium is a glass. So this is air, this is glass, and when light enter from here, this is a normal, enter here, it's not goes like dot dot points due to the light goes what rare medium to denser medium, it's change its path, it's bend in here real path, and after when it's coming out emergent, it's follow their same paths, so it's once again bend out. So this is the happen due to refraction of light through a rectangular glass slab. Okay. Next is, so there is a representation how we represent a properly, and all notification is given. Okay. So now you are familiar with the refraction of the light here. Refraction of the light. Refraction is due to the change in the speed of light as it enters from one transparent medium to another. Experiments show that refraction of light occurs according to the certain law. According to the law of reflection, here is also two law of refraction, which is a little bit same, but second one is different due to the rarer and denser medium. Okay, first one is the same, the incident ray, the refracted ray, and the normal to the interface of the two transparent medium at the point of incident all lie in the same plane. Second, the ratio of sine of angle of incident. The ratio of sine of angle of incidence and sine of angle of refraction is a constant for the light given color and for the given pair of the media. This law is also known as Snell's law of refraction. So from where it's come? So go about here to understand this in this figure. You know from where sine I and sine R is come. So look at this. This is also a triangle which is a right angle triangle. This is also a right angle triangle. So what is sine? Sine is equal to perpendicular upon hypotenuse. So where is the perpendicular and where is the hypotenuse? Here is the hypotenuse and here is the perpendicular. This is the ratio because angle of incidence is here. So sine I, the angle of incidence, the ratio of sine of angle of incidence and the ratio of sine of angle of refraction R and I will be constant in the case of refraction. Okay students, come back to the topic. Sine I upon sine R is equal to constant. The constant value is also called refractive index of the second medium with respect to the first medium, because second medium is a denser and first medium is a rarer. So let us study about refractive index more. What is a refractive index? Different dense medium have a different refractive index, means the ratio will be constant in the medium. Here is the table. Like for air, the refractive index 1.003, for ice 1.31, water 1.33. When we go denser, like at the bottom, crown glass 1.52, and the last diamond is 2.42. So it is also defines refractive index is the can be linked to an important physical quantity, because the ratio in the science is also denote the speed. Speed is equal to distance upon time. Okay, so the triangular ratio is also show the physical quantity speed. So we know that the light travel fastest as vacuum speed 3 into 10 power 8 meter. So because we are dealing with the problem of light, so we take as a speed of the light, how it's behave in the different medium like air, glass, diamond, whatever. Okay, so go ahead here, n21. If we represent like this, there is a two medium 1 and 2 and both speed v1 and v2. So 1 minute. If there is a speed v1 and v2 and medium is 1 and 2, so it is represent like this, can be expressed as in equation n21 speed of light in medium 1 upon speed of light in medium 2. So overall v1 upon v2, this one v1 and v2. Okay, same thing is also applicable when we reverse the medium. N12 is the speed of light in medium 2 upon speed of light medium 1, v2 upon v1. So we can say that where we need, from where the light goes, if it is goes rarer to denser, then we use this one. When it goes denser to rarer, or any medium, if 2 1 to, if it goes 1 to 2, so we n to 1, if 2 to 1, so 1 2. It is depend upon the application. So overall, at the conclusion, nm, like speed of light, generally goes from air to any medium. So just simply speed of light in air upon speed of light in the medium, c upon v, we take it. Now understand this in the figure. This one, like a medium 1 air and medium 2 glass, and n is the normal, I is the angle of incidence, and r, small r, is the angle of refraction. I is the incident and refractive angle. Okay, so this is overall representation of refractive index. Same, you have to learn this table, because this table is very important for the numerical purpose. When mostly the numerical in the exam is come from belongs to air, ice, water, crown glass, and diamond, basically. So we must learn this value. Next, more to know, the ability of medium to refract light is also expressed in terms of optical density. Optical density has a definite connotation. It is not the same as mass density. We have been using the terms rarer medium or denser medium in this chapter. It actually means optical rarer medium, and optical denser medium in lots of books. So we avoid it for better understanding and for easy to concept. When can we say that a medium is optically denser than the other? In comparing two media, the one with the larger refractive index is optically denser medium than the other. The other medium of the lower refractive index is optically rarer. The speed of light is higher in rarer medium, obviously, and lesser to the denser medium. The ray of light traveling from rarer medium to denser medium slows down, bends towards the normal. When it travels denser medium to rare, it speeds up and bends away from the normal. Basically, which already I told you. So this is the question. A ray of light traveling in air enter obliquely into water. Does the light ray bends towards the normal or away the normal? So when it go air to water, it go in dense medium, so it's bending. Second, light enters from air to glass having refractive index 1.50. What is the speed of light in the glass? The speed of light in vacuum is 3 into 10 power 8. So just simple, you can solve it. N is equal to, second question, air to glass, speed refractive index is 1.5. So here you put directly the value of n, that is 1.50. Therefore 1.5 is equal to speed of light in a air above upon the speed of light in the vacuum. What is the speed of light in the glass? So you write here speed of light in a glass, ऊपर लिखेंगे 3 into 10 power 8 मीडियम. सो स्पीड ऑफ ग्लास माने VG मान लीजिए इज इक्वल टू 3 into 10 power 8 upon 1.5. So which is basically velocity in the glass is equal to 3.5 divided by 1.5, 2 into 10 power 8 meter per second. Okay. Next question. Find out the table 10.3, the medium having highest optical density. Also find the medium with the lowest optical. So highest optical density is diamond, lowest is the air. Fourth, you are given kerosene, turpentine and water. In which this does the light travel faster? So which one is the rarer? It's depend upon that. In rarer medium, it goes faster. So in kerosene, turpentine, water, which density is lower? So by which you can easily find out. the last question, fifth one. The refractive index of diamond is 2.42. What is the meaning of this statement? So you can find out here by putting the formula. N medium is equal to refractive index, speed of light in vacuum and speed of light in a diamond. So the speed of the light in the diamond is slow. So we saw that the statement means diamond is a very optically dense. Next topic is refraction by the spherical lenses. Okay, same thing is happen. Now we are going to understand convex lenses and concave lenses. Generally, convex lenses are converging lens. It is written here or not? And the concave lenses are diverging lens. Hence, convex lens are called converging lens. Like convex, outer surface is vex. Concave, it is a diverging lens. So when the white light goes straightly, it converges. Okay, at a same point. When a white light strike on the surface straight, it diverges. So that's why it is a diverging lens. The question is why it is diverge or converge. For that we have to learn some basics rule of formation. Here is the formation. First one is the A is the converging, second is the diverging. Okay, image formation by lenses. So also we have to learn some basics rules. Where is the f1, f2, 2f, 2f3, or f1, f2, 2f1 and 2f2 is found. What is center of curvature? For here optical, what is optical center? These things, it is overlap with the reflections also. So be careful and learn the basic things. Let's discuss image formation by the lenses. So these are the 6 cases. First we put the object very far at infinity, here at infinity, to very close at optical center. So all these 5 cases, real and inverted is found, and last case virtual and erect. And size of image is enlarged in when it is very far away, diminish when it comes closer, diminish, and when you put at the 2f1, basically center of the optical lens, it becomes same size and then it's going to up. So let's understand by this image formation. What is the basic rule for line drawing? So you have to learn this, some basics rules which is very important to understand. So when a light strike parallel to the principal axis, it passes through its focus. When it also for applicable for diverging, it's diverge, but it appears to meet at a virtual focus. So very simple, when the light strike any lens parallel to the principal axis, is after refraction it passes through its focus. Second, when a light passes through a principal focus after refraction from a convex lens, will emerge parallel to the principal axis. This one, A and B. Here line is passes through the focus, so it goes parallel. It when it's for the diverging is going to the focus, after diverging it becomes parallel to the principal axis. Third one, when it goes through a optical center, no deviation is come, it goes directly without any deviation. Okay, so these 3 rules is help to drawing image formation by concave mirror, or this 6 figure. Okay, let's understand how it's work. So be careful and quick. In the first case, light is passes parallel, so after refraction it goes converging due to the lens. Okay, so parallel means the line comes from the infinity and image is formed at focus, very short and diminished. In second case, B point, when the object placed beyond 2f1, so when one light parallel, it passes through its focus. Second, with optical center without deviation, so the image is formed real and inverted. Real means which is in front of the lens, and inverted below down the principal axis. And the size, look at here, the size of the figure objects means image will be shorter than the object. Third case, for a third case we understand here C point. Okay, so for that object is placed at 2f1, so it is formed, image is also formed 2f1, same size, real and inverted by looking figure, and the principle is same. When it's parallel, it passes its focus. When it is optical center, passes through. After refraction, no deviation come. So that is the third one. Now move closer. Closer means your object is placed between 2f1 and f1. Here, somewhere here. So same, one from the optical center, another for the parallel. So it's meet at beyond C. And by looking the figure, your objects and image size is bigger than your objects. Okay, now move for next case, E case, which is more closer than third one. So for E case, your object is placed between at 2f1 or focus. So when it is put on the focus, your image form parallel, so it means it appears to meet at infinity, so your object become enlarged. Okay, and form at infinity. Last case, when the object placed between f and optical center. Okay, here your object is placed here, and same, when one rays is passes optical, another is parallel. Parallel is passing through after refraction focus, so it's not meet here, it's all two lines are going apart to it, so there is no chances to meet here, so there is no real image. So when we appears to meet at the back side, it may be meet. So here is the real, virtual and erect, due to the images from upper side, so it is a erect also. So in this case, image become enlarged and virtual and erect. So these are the 6 cases. So, and in the case of concave lens, so wherever you put at infinity and second between infinity and optical center, all time the image is formed diminish. So, and virtual and erect, same side of the lens. So let's see where it is formed. Okay, look at this, the rule is same. Now comes on this. So if any object is placed infinity, so it, in that case, object is placed or come parallel line, and after divergence it appears to meet at a focus, so it is highly diminished pictures image found here. Second case, when your object is placed anywhere optical center and at infinity, so here one is goes parallel, after divergence it's back, appears to back at focus and optical center, and when it's come back goes there and one comes back, so it is formed here, and the size is also diminished than object. So these are the image formation by the concave lenses. Now it's time to understand sign convention for spherical lenses, because it is most important for the numerical. So there is no need to learn this, because the sign convention is same for the spherical mirror and spherical lenses. Now next one is the lens formula and magnification formula. So lens formula is a different. Lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. And once again 1 upon V minus 1 upon U is equal to 1 upon F. Let's talk about magnification formula. Magnification is the same. Height of image is equal to height of object upon height of object, h dash upon h. Another formula is V upon U. Remember, here is a positive sign. Okay, and for the lens formula it is negative here. If you want to compare with the mirror, so lens formula become plus here 1 upon V plus 1 upon U is equal to 1 upon F for the mirror formula. Okay, and for the this magnification formula it will be minus. For red, say red color pencil mark is the formula for the mirror. So this is the mirror formula and mirror magnification formula, and everything is same. Okay, so now it's time to solve the numerical. That is very important. Okay, last one. A concave lens has a focal length of 15 centimeter. Positive sign is given. So what is mean? At what distance should be the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Image is also given. V is also given minus 10 centimeter. Why minus 10 centimeter? Now understand. First we are going to explain everything. Like concave lens. Concave lens means all image is from virtual. So image minus means it is virtual image, and focal length is 15 centimeter. In case of concave lens, since focus is also virtual, so it is minus 15 centimeter. Okay, what is question? Also find the magnification produced by the lens. ऑब्जेक्ट भी बताना है और मैग्निफिकेशन भी बताना है. ओके, सो बाय पुटिंग द लेंस फॉर्मूला 1 minus V minus 1 upon U is equal to 1 upon F. You put all the value with the sign here, minus 10 and minus 15, and calculate it. So U become minus 30. Minus is so opposite to the incident, so your value is right. If not, minus is not come, so there is a something is mistake in the putting sign convention. Next is magnification. So put the formula of magnification. M is equal to V upon U. Put the value with the sign. So plus 0.33 is come. Okay, so plus sign is shows that image is erect and virtual because it's come positive, na? And the image is 1/3 of the size of object. Next example 10.4, and it is the convex lens, converging lens, which is gives all time real and inverted. In but one cases there is a virtual image. So let's check out what kind of image is given here. A 2 centimeter tall object is placed perpendicular to the principal axis of convex lens of focal length 10 centimeter. Focus is real, so here real means positive, but in the mirror is negative. So remember these things, it comes after lots of practice. The distance of the object from the lens is 15 centimeter. U is given. U always given taken in the minus sign. Okay, so remember it. F is positive due to the real focus. Height of object is 2 centimeter. Find the nature, position and size of image. Also find its magnification. So just simple for image, position of image means finding U, we need to put the formula, lens formula 1 minus V minus 1 upon U is equal to 1 upon F. When we find 1 upon V, this become like this. By sending 1 upon U in another side, minus become positive here. Okay, so simply put all the values here and calculate it. What comes? 1 upon V is equal to 1 upon 30. So V is equal to plus 30 centimeter. What is the plus sign means? The image become what? Real, because here focus is real, which is given in the plus sign. Okay, so V is come plus 30 means real. It is written here. Positive sign V shows that the image is from distance 30 cm. In other side optical center and image is real inverted. Now understand by the image formation. Simply image formation. Now understand. Your focal length is a 10 centimeter. Okay. Now draw it. This is a convex lens and your focus at 10 centimeter. Okay. Somewhere here. And your object is placed where? U is 15. Somewhere here. Far away. When white light is straight light, it passes through its focus and one goes its optical center, it's meeting here. So your object is placed between f1 and 2f1 and your image is from beyond 2f1. You understand, huh? This is the case which is already given. Now it's time for magnification. H dash is equal to H dash upon H is equal to V upon U. By putting all the value is come M is equal to minus 2. Minus 2 is shows that the sign is shows that it is inverted but enlarged. The negative sign shows that image is inverted and real from the principal axis. Okay. So by this way you understand very well numerical. We also practice in the next video. Next topic is power of lenses. Power of lenses is very simple. P is equal to 1 upon F. F is given here in the meter. In most cases whenever you want if it is given centimeter, so you change this formula. P is equal to 100 because 1 meter is equal to 100 centimeter. 100 upon F. Here F is calculated or taken in centimeter. So centimeter divides centimeter. What is the unit of power of the lens? That is diopter. SI unit of the power is a diopter here and it is represented by capital D. So you can also find with the help of power of the lenses. So if plus sign is given, so means focus is plus. Where found the focus is plus? In case of convex lens. And if this is minus 2.5 diopter, so it is a lens concave. Okay, it is a convex. So when the value comes positive, it is a concave, and when the value is come negative, it means it is a convex lens or concave lens. Simply this is the overall chapter explanation. This is question. What you have learned. Do the practice. More question. We will also solve this question. Okay, till then, thank you for listening. If you like this video, please like it, share and subscribe also. Thank you for your appreciation.